Okay, let's take a look at how the degree helps us out with determining the endpoint behavior, or sometimes we call it the end behavior of a polynomial. So starting off with p of x equals negative x to the sixth plus x to the fifth minus 3x squared minus x plus 50. If the only thing they're asking for is the endpoint behavior, what we want to first determine is what is the degree, and sometimes it also helps to identify who the leading coefficient is. So first off, I will mention the degree of the polynomial. In this case, it's the exponent on x, the highest exponent, and it looks like we have the 6. So once I can determine the degree, what I do is just ask myself, is this an even or odd number? And 6 is an even number. So we have an idea at this point. This is going to narrow down our end behavior as either both ends pointing in the same direction. So we could either have up, up, or we could have down, down. So at least we've narrowed it down to 2 choices. The next thing I'll address is what the leading coefficient is. And again, everything has to kind of do with the leading term. So I'll kind of circle that. The leading coefficient is equal to -1. And so if we're dealing with a negative leading coefficient for this type of polynomial, this is going to indicate that both of the ends of our polynomial are both going to be pointing down. So this further narrows down our choice. And so we have the end behavior of p of x. So let's move on to q of x. Same idea. We will identify who the degree is. So I see the highest power of x. And for the most part, you notice that the highest power of x, these polynomials seem to be working out in descending order. But if that's not the case, just be on the lookout. Just scan all the terms to make sure that your leading term definitely is in front, or find it if you have to. The degree for q of x is actually equal to 3. And so what all understanding is saying, okay, is 3 even or is it odd? And I do know it's an odd number. And so this is going to help us indicate end behavior is either going to have opposites, so down, up, or up and down. So what I try to understand now, before I make my final decision, narrow it down to the final answer, I'm going to take a look at my leading coefficient. And in this case, my leading coefficient is 9, and that's a positive number. So that is going to indicate that my end behavior will be down then up. And I'll give you a hint in a little bit about how we can narrow it down without having to have everything memorized. Sometimes our TI is going to help us out if we have the nice clear function, but I'll give you a shortcut. Okay, so let's see, a last one for R of x. Let's take a look at the degree. And we're looking, the leading term happens to be negative x to the 7th. So I see that my degree is 7. And it is an odd number. So that's again going to help us indicate that the end behavior is either down, up, or I'll move over just a little bit, up, down. To further narrow down our selection, we'll note that the leading coefficient is -1. And that reminds us, okay, that's a negative number. So that's going to tell us that our end behavior is in fact up first on the left and then down on the far right. So it's very useful to help us have an idea of what our polynomial is going to look like. It helps us determine the appropriate window if we need to widen it out. But I would like to point out a few things just to help you out a little bit more. What I like to do is kind of focus back on some of my favorite parent graphs a little bit. So just a little bit of a note off to the side. So a lot of you are familiar with the y equals x squared. That's a nice parent graph. We have a parabola. And what you can do for yourself is you could kind of use this idea to help you out with any sort of even degree function. So notice that 2 is an even number. So we kind of know if we have a positive leading coefficient, we know that both ends are going to point up, up. You can then kind of take a look at what would y equals negative x squared look like. And if you're not sure, you just forgot at the moment, you still kind of notice that you have an even degree, but you could use your TI to graph it really quick without needing to modify any of the windows, and you will notice that, oh yeah, they've got this down, down issue. So kind of with this sort of idea, if you were to look back at part A, that's x to the 6th, we could kind of use this as a mini shortcut and say like, okay, at least with even degrees, I know that the directions are always the same. It's either up, up, or down, down. And then just kind of keeping this in mind, if you're kind of looking at what's the pattern on the nice version of your parent graph, you'll notice that if you had a positive exponent, or not exponent, excuse me, positive leading coefficient, you notice that it's going to be an up, up case. So then when you kind of look at your P of X, you notice, oh, it's a negative leading coefficient. And that kind of gives you the idea of, oh, that's why we're going to choose the down, down version for part A. So kind of a shortcut in a sense. You still kind of have to have the idea of the both ends pointing up or down, but this could help jog your memory. And I'll use the same sort of idea to kind of help you out with Q of X and R of X, B of C, part B and part C. You can look at one of our favorite parent graphs, y equals x cubed versus y equals negative x cubed. And this could kind of give you an idea of what it looks like. So just kind of pointing out that we have an odd degree in both of these cases. It's a nice odd degree. And you could either use your TI or your past experience, but I do know that these graphs kind of have this sort of behavior. And so when you have a positive leading coefficient, you end up having the case of down, then up. So that could kind of give us a clue about looking at maybe, I believe it was Q of X. We saw that it had a positive coefficient, and that's why we had the down then up. So it kind of gives us a hint, even though we might be, the degree might be higher. Right now it's at x cubed, but the parent graph helps us out. And similarly, if you were to look at the graph of y equals negative x cubed, you kind of see it has almost the same behavior, but it actually starts off as up, then down. And then you notice, oh yeah, it does have a negative leading coefficient, so that's going to help us out with the pattern. So that could help us translate, well, if we do look at R of X, we kind of notice the same idea. Oh yeah, odd degree, even though it's not x cubed, but it does have that same sort of possibility. We have that negative leading coefficient, which is further justifies why it's up, down. So hopefully between the two concepts that we've talked about here, you have a better idea of how to identify the endpoint behavior without having to even graph the function. It will save you a lot of time if you could kind of learn the concepts this way. That way we don't have to spend too much time typing stuff in unless we really need to calculate specific points of our function.